All right, so today in Algebra 2, we're going to start Chapter 6. We're going to do the first half of Section 6.1, Key Features of Exponential Functions. Our essential question for Chapter 6 is how do you use exponential and logarithmic functions to model situations and solve problems? 6.1's essential question, how do graphs and equations reveal key features of exponential growth and decay functions? After 6.1, you should be able to recognize the key features of exponential functions. We're going to focus today on graphing exponential functions, and that's all that we're going to focus on today. Okay? So let's start out and talk about what is an exponential function. So we're going to start out here, an exponential function. So an exponential function is any function of the form y equals a times b to the x power, where a and b are constants as long as a is not equal to 0, b is greater than 0, but b cannot equal 1. So we're going to look at this first one. We're going to identify the domain, the range, the intercepts, the asymptotes, and the end behavior of each function, and then we're going to graph it. So we see number 1 says f of x equals f of x equals 2 to the x power. We want to identify our a and our b. B is always whatever is being raised to the x power. So here b is 2. A is the number in front of that. Okay, there's not a number in front of 2, so that's understood to be a 1. Okay, so I can go ahead and make an XY table. On this first one, we're going to go ahead and graph it, and then we'll come back and talk about domain, range, intercept, asymptote, end behavior, and all of that after we have graphed it. And then we should be able to identify those things without graphing them. Okay? So x, I can pick any number I want to plug in for x. So let's just do -2, -1, 0, 1, and 2. So if I plug that in, 2 to the -2 power, remember I can't have negative exponents, so to make them positive, so right now I have 2 to the -2, I move it to the denominator, so that's like 1 over 2 squared, so that's going to give me 1/4. 2 to the -1 would give me 1/2. 2 to the 0, anything to the 0 power is 1, so this is using all of our properties of exponents that we have learned previously. 2 to the first power is 2, 2 squared is 4. So now let's just plot these points. So 2, 4, 1, 2, 0, 1, -1 up 1/2, -2 4th. All right. If I'm going to draw this graph, okay, let's see if I plugged in -5. Okay, so let's just see what's happening here. If I plugged in -5, I would get 1 over 2 to the 5th, 32. Okay. So notice that we're getting very, very small, very close to 0, but we're never going to get 0 as a y value. So I'm getting very close. This is my graph. So let's talk about the domain. The domain, we said we could pick any number we wanted for x. So our domain are all real numbers, or -infinity to infinity. Our range, okay, again, we said that we're not going to get to 0, right? We're not going to have any negative numbers here. And so my range is, I can either write it as, that would be a parenthesis, 0 to +infinity, or y is greater than 0. My y-intercept, that's where it crosses the y-axis. I see that is at the point 0, 1. My asymptote, okay, remember that the asymptote is the line that your graph approaches. And so here my asymptote, and we're going to draw that dotted line. Okay. So here my asymptote is y equals 0, which is also known as the x-axis. Okay. So now in behavior. And in behavior, we're not talking about down, up, down, those types of things, okay, when we were doing our polynomials. So here we're going to actually label it. As x approaches -infinity, what does y do? So as x approaches -infinity, as my x's are getting smaller, look at my graph, what's happening to y? Y is approaching 0. So now let's look at as x approaches +infinity. So as my x's are getting bigger, my y's are also getting bigger. So then I could say y approaches +infinity. Okay? All right, so let's talk about this a little bit. So what do we notice? We notice that our If I didn't have an a that was bigger than 1, right, then my asymptote was at y equals 0, and I don't have anything being added or subtracted to my x or to the entire function. So my asymptote is at y equals 0. That's the basic, okay? I don't have anything being added or subtracted to the x or to the entire function. So then my y-intercept is that 0, 1, okay? This would be known as like a parent function, okay? So 2 to the x would be the parent function of any 2 to the x, okay? Once I have any kind of transformations with x like +4 or +2 or -1 or anything being added or subtracted at the end or anything being multiplied out front if I had an a bigger than 1. So this is my basic parent function, but we could have transformations done from this. So let's look at one that has a number other than 1 for a and see how is this different. So here I get f of x equals 5 times 1/2 to the x power. So here my a is 5, my b is 1/2. My domain, the nice thing about these, my domain, I can still pick any number I want to. I know that my domain is going to be all reals. Okay? I'm not going to have any zeros or negatives. Okay? So again, I don't have any vertical shifting going on, so my range is still going to be from 0 to infinity, or y is greater than 0. Okay, let's make an xy table here of this one and see what happens. Again, we're going to pick like -2, -1, 0, 1, and 2. So if I plug in -2, 1/2 to the -2 power, that becomes 2/1 squared, right? So I would have to flip that. So that becomes 4. 4 times 5 is 20. 1/2 to the -1 power. Right? Again, I would flip that, and that would become 2 to the first power is 2. 2 times 5 is 10. 1/2 to the 0 power is 1, but then once I multiply it by 5, I get 5. 1/2 to the first power is 1/2. 5 times 1/2 is 5 halves. 1/2 squared is 1/4. 5 times 1/4 becomes 5/4. So I can plot these points. So 0, 5, there's my y-intercept. -2, we're somewhere way up there at 20. -1, way up there at 10. Over 1, we're up like 2.5. Over 2, we're up a little bit past 1. And again, this is going up to get very close to my x-axis, but it's not going to touch it. So I'm going to do my asymptote dotted line. So again, I see that my asymptote is y equals 0, or the x-axis. My y-intercept this time was 0, 5. Whoa. 0, 5. My end behavior, so we're going to look at as x approaches positive and negative infinity. What does our y do? So as x approaches negative infinity, as my x's are getting bigger, my y's are getting bigger, so y approaches positive infinity. As x approaches positive infinity, so as my x's get bigger, what's happening to my y's? They are approaching 0. So there's my end behavior. So let's look at the difference between this one. My y-intercept. Notice that my y-intercept changed. It's not at 0, 1 anymore, it's at 0, 5. But look, what is my a? My a was 5. Okay? So a plays a role in our y-intercepts. Okay? So again, our a will play a role in our y-intercept here. Okay? All right, let's go to the back. Identify the parent function. Use your knowledge of transformations to graph the new function. Okay? So f of x equals 3 to the x power, all that minus 4. My a is 1, my b is 3. Okay? My domain, again, is going to be all reals. That's the nice thing about these. My range, we're not going to do range yet. Okay? The parent, okay? The parent function to what we're graphing would be 3 to the x power. So let's look at an xy table for the parent. So if I plug the -2, 3 to the -2, that would become 1 over 3 squared, which would be 1/9. 3 to the -1 would be 1/3. 3 to the 0 would be 1. 3 to the first is 3. 3 squared would give me 9. Okay? So now we want to look at our new one, the 3 to the x, all of that minus 4. Same type of transformations, okay? I don't have anything being added or subtracted with the x, so it's not going to have any kind of a horizontal movement. It's not going to move left or right. I have minus 4 out here at the end, so that means that my whole graph is shifting down 4. So again, I would just do y minus 4. I don't have an a out front, so I don't have to worry about anything being multiplied. So all of my x are staying the same, -2, -1, 0, 1, and 2. All of my y's, I'm going to subtract 4. 1/9 minus 4 gives me -3 and 8/9. 1/3 minus 4 gets me -2 and 2/3. Sorry, -3 and 2/3. 1 minus 4 gets me -3. 3 minus 4 gets me -1. 9 minus 4 gets me 5. And remember, this is what we're interested in. So plot those points. So over 2 up 5. 1 -1. 0 -3. -1 -3 and 2/3. -2, -3, and 8/9. So this time, what number does it look like I'm going to get very, very close to, but not touch that -4? So here's my graph. Whoa. Let me see if I can get rid of that. Okay, we'll go back. All right, so my asymptote this time is that -4. So there's my asymptote. Okay, so notice that my range changed. This time I have some negative numbers and I have 0 as well, okay, in there. So my range is going to be from -4 to infinity, or y is greater than -4. My y-intercept was at 0, -3. My asymptote is now the line y equals -4. My end behavior, so as x is approaching negative infinity, what's y doing? As x is approaching positive infinity, what is y doing? As x approaches negative infinity, y approaches -4. As x approaches positive infinity, so as my x's get bigger, my y's also get bigger, infinity. So let's look at our asymptote first, because it changed. This is the first time we've seen our asymptote change. So the asymptote, okay, became what was being subtracted, right? This, and remember from our formulas, we could have y equals a b to the x minus h, all of that plus k. So we would still have our a, our h, and our k's in these transformations. So our asymptote becomes y equals k. So if I don't have anything being added or subtracted, my asymptote is 0. If I have something being added or subtracted, that becomes my asymptote. But notice that also, our asymptote is also our range. It affects our range. So our range is dependent on k as well, which makes sense because k is our vertical shift, right? Let's look at our y-intercept now, because our y-intercept also changed. So before, we were looking at a y-intercept of 0, 1, and then we had a y-intercept of 0, 5. So now let's talk about what our y-intercept went. Okay? So our y-intercept went from 1 to 1 plus k. Again, that's because I did not have an a value out front. Right? If I have an a value, then that a value is also going to affect my y-intercept. Right? But here I don't have an a value. I have a k. So 1 plus my k puts me at my y-intercept here. Okay? So there's our graph. So let's look at another one of these. So here we're going to do h of x equals -3 to the x power. It still has the same parent, 3 to the x, right? So we can still write its parent. We'll just write it down here again so that we could see where we were at. We don't have to scroll back up. So this was 1/9, 1/3, 1, 3, and 9. So now my new one, it's -3 to the x. My A here is -1. My B is 3. My domain, still all reals. I can plug in any number I want. Okay? So my range, let's talk about this. Okay, so my x's, again, my x's aren't going to change. That A value, remember that A value? We multiply that by our y's. Here my A is -1, so basically I have negative y. Not adding or subtracting anything. So my x's all stay the same. My y's all become negative. So now if I want to graph these, so over 2 down -9, and somewhere down here, or 1 down -3, 0, -1, -1 down -1/3, -2 down -1/9. Again, I'm getting close to that x-axis, but I'm not going to touch it. So my asymptote, again, is the x-axis. Okay. So my asymptote, again, y equals 0, the x-axis. Remember, we talked about up there that the asymptote was dependent on k. We did not have a k, right? So my asymptote didn't change. It didn't go up or down. We said that our range was also dependent on k, but also remember, okay, that negative out in front, that's like the reflection, remember? So now my range, instead of being 0 to infinity, it's -infinity to 0. Or y is less than 0. My y-intercept is 0, -1. My end behavior, as x approaches -infinity, what is y doing? So as my x's get smaller, my y's approach 0. As x approaches positive infinity, my y's approach -infinity. So here again, we notice that our y-intercept changed, okay? I did not have a k value. So if I don't have a k value, my y-intercept is 0, a when there is no k value. Okay? So my a was -1, so 0, -1. Again, we saw on number 1 up here, when I had a k value, that k value, okay, I had to add to my 0, a y-intercept. Okay, so a and k can affect our y-intercept. All right, so we've graphed 4 of them. So we're just going to go to the next page and look at the top of the next page. We're not going to graph these. We're just going to answer the questions of how do the asymptote and y-intercept of the given function compare to the asymptote and the y-intercept of the parent function. Okay. So first, number 1, g of x equals 5 to the x plus 3. Its parent is g of x equals 5 to the x. Okay. So the parent asymptote, the parent y-intercept. Okay. The parent asymptote, again, I don't have anything being added or subtracted out here on the parent, right? So my parent asymptote is always, y equals 0. Let me change that, make that better. Y equals 0, the x-axis. The parent y-intercept is always 0, a. My a is a 1 here, so my y-intercept would have been 0, 1. So now the new one, so 5 to the x plus 3, the asymptote. Again, what affects my asymptote? K value. I don't have a k value, so it's the same. It's still y equals 0. That didn't change. My y-intercept, though, so let's go back to, I made a mistake there when I said that my y-intercept of the parent was 0, 1. Okay? Remember, if we did our xy table, if I did my xy table, if I plugged in 0 for my x, okay, 5 to the 0 power, sorry, I need, is, sorry, 0, comma 1. Okay? So now 5 to the x plus 3, the y-intercept is going to be 0, comma. Okay? So if I put 0 in there, okay, for this x, I get 0 plus 3, which is 3. So 5 cubed, which would be 125. Right, let's look at the second one. H of x equals 5 to the negative x. Again, we have the same parent, okay? So this time, my asymptote, again, is still y equals 0. My asymptote hasn't moved. My y-intercept, okay, so I see that this time what has happened, it's a negative x. Well, what happens if I plug in negative 0? Nothing. So my y-intercept is still 0, comma 1. So this time it is unchanged. Okay? So my asymptote, remember, is affected by the k value. My y-intercept is affected by an a value, okay, as well as a k value. Okay? I did not have that on either one of them, so I didn't have to worry about that. However, my y-intercept can also be affected by that h value right there. So if I plugged in 0, I ended up with 5 cubed. Okay? So we just have to watch out for what's happening to my asymptotes, my y-intercepts, things like that. All right, so that's going to do it for our first day of section 6.1, graphing or exponential functions. So your homework will be a graphing worksheet. It's called 6.1 worksheet number 1. Tomorrow we will finish up section 6.1 without the graphing. We will learn more about the functions themselves, but not graphing them.